one of NASA's own claims that Voyager 1 has communicated with an alien power. The Voyager probes, which have been exploring the solar system for almost 40 years, have now entered the frontiers of deep space, which further implicates that Voyager 1 just made contact with a massive structure in space. After Voyager 1 made contact with a massive structure, scientists have been curious to discover more about the mystery surrounding these incredible events. Recently, an equipment detected a shift in the magnetic field around the spacecraft, suggesting the possibility of a magnetic influence. Because the noise was so loud and lasted so long, NASA scientists began to doubt their original theory that a cosmic ray or high-energy particle speeding across space was to blame. Everyone on Earth has been taken aback by Voyager 1's discovery of an unknown force in outer space. NASA scientists speculated that an unknown factor was causing the magnetic field around Voyager 1 to fluctuate in a way they could not explain. The spaceship almost collided with an invisible wall. NASA researchers are always probing the nature of this enigmatic energy. They are looking into many other possibilities, such as the existence of alien intelligences and strange astronomical events. Dark matter has been blamed for the disruption by some. Researchers has been taken aback by Voyager 1 making contact with a massive structure in space. On December 15, 1977, NASA's Voyager 1 spacecraft departed the asteroid belt ahead of its sister ship Voyager 2 due to its faster cruising speed. When it began its Jovian imaging mission in April 1978, it was around 165 million miles, 265 million kilometers, from the planet. Images of Jupiter's atmosphere that had been returned by January 1979 showed that it was more turbulent than it had been during the Pioneer flybys in 1973 and 1974. On January 30, 1979, Voyager 1 began its 100-hour photography mission, during which it took a picture every 96 seconds. The resulting color time-lapse film covered 10 Jupiter spins. The probe arrived in the Jovian moon system on February 10, 1979, and by the beginning of March, it had discovered Jupiter's narrow, less than 30 kilometers or 19 miles thick ring. The sudden and unexpected shift in the spacecraft's magnetic field measurements implies an unseen external factor may be to blame for the disturbance. Voyager the 1st of May have been hit by an as-yet unidentified cosmic ray, which might account for the unexplained power. It is believed that these high-energy particles, which can affect the behavior of charged particles in the heliosphere, originate from beyond our solar system. An alternative explanation is that a coronal mass ejection is to blame for the disturbance. This is a major solar plasma outburst that has the potential to disturb the ionosphere. The magnitude and duration of the disruption detected by Voyager 1 raises greater concerns about the origin of the mysterious energy than was first thought. Voyager 1 found 5 new moons, a complex ring system with thousands of bands, transient clouds of minute particles in the B ring that have been dubbed spokes, a new ring, the G ring, and shepherding satellites on either side of the F ring that maintain the ring's sharp edges. Titan, Mimas, Enceladus, Tethys, Dione, and Rhea were all photographed by the spacecraft during its flyby of Saturn. Incoming data indicated that all of the moons probably consisted of water ice at their cores. On November 12, 1979, at about 5:41 UT, at a distance of about 2,500 miles, 4,000 kilometers, Voyager 1 flew by Titan. Voyager 1 was sent on a path to depart the solar system after its collision with Saturn. It is now traveling at a speed of around 3.5 AU, 325 million miles or 523 million kilometers per year, 35 degrees north of the ecliptic plane, and roughly in the direction of the Sun's motion with regard to neighboring stars. Because of Titan's flyby's specific requirements, the spacecraft wasn't aimed for Uranus or Neptune. On February 14, 1990, Voyager 1's cameras were pointed in the other direction, creating the first portrait of our solar system as seen from beyond. These images were taken at a distance of 40 astronomical units, 3.7 billion kilometers or 6 billion astronomical units from the Sun. The new mission's overarching goal is to expand NASA's solar system exploration into the outskirts of the outer planets, to the reaches of the Sun's influence and beyond. Data collection on the boundary between the heliosphere and the interstellar medium is a specific goal. Each Voyager is equipped with a gold-plated copper disc measuring 12 inches, 30 centimeters in diameter, bearing a message to any prospective extraterrestrials who may come across the spacecraft. This disc was created by a team led by Carl Sagan. The record, like the plaques on Pioneers 10 and 11, shows the relative positions of Earth and many pulsars through the use of symbols. Instructions for utilizing a cartridge and a needle, like with a conventional record player, are included. There includes 90 minutes of mostly Western music, from Mozart and Bach to Chuck Berry and Blind Willie Johnson, and greetings in 55 different languages. There are also 35 Earth noises, such as whale calls and laughing. It also has greetings from Jimmy Carter, 1924 to present, and Kurt Waldheim, 1918 to 2007. Two previous Secretaries General of the United Nations. Almost 11 billion miles, 18 billion kilometers, separate the two Voyagers from the Sun and its warmth. In 2019, mission engineers began implementing a new approach for managing the older robots to ensure they continue producing the highest quality scientific data possible. The method entails making tough choices, especially with the spaceship's sensors and propulsion systems. With the exception of the photopolarimeter tests, all of Voyager 1's Jupiter-related endeavors were fruitful. Scientists re-evaluated previous atmospheric models that failed to account for the unique occurrences after discovering that Jupiter's atmosphere was more active than it had been during the missions of Pioneer 10 and 11. The mission surveyed the moons Amalthea, Io, Europa, Ganymede, and Callisto, providing the first detailed look at their surfaces. Of all of Voyager 1's discoveries, the revelation that Io contains enormously active volcanoes heated by the moon stretching and relaxing every 42 hours as it travels closer to and then further away from Jupiter is arguably the most remarkable. Scientists' conceptions of the moons have to be revised after this finding. After Pioneer 10, Voyager 1 was the second spacecraft to complete an orbit around Saturn. It examined the planet, its rings, its moons, and its magnetic field more carefully than its predecessor, Pioneer 11. Voyager 1 accomplished all it set out to do with one notable exception, the photopolarimeter tests. The spacecraft found the moons Prometheus, Pandora, and Atlas, which it describes as shepherding the F ring and shepherding the A ring in a similar fashion. In August of 2012, Voyager 1 became the first spacecraft to travel into interstellar space. As long as we continue to include the Sun and everything that primarily circles the Sun in our definition of the solar system, this object will remain within the solar system until it exits the Oort cloud sometime in the next 14,000 to 28,000 years. In October 2022, researchers discovered peculiar formations and ripples marking the transition from the solar system to the vastness of interstellar space beyond. The results show that the heliosphere, which surrounds the solar system and protects it, fluctuates in ways that are intriguing and potentially controversial, as the authors puts it. The heliosphere reaches out into space for around 11 billion miles, which is more than twice as far as Pluto's orbit. It is the solar wind, a stream of charged particles emitted by the Sun, that is responsible for molding the heliosphere. This structure ends at the heliopause, when the solar wind is overwhelmed by the interstellar medium's forces. The NASA Voyager 1 and 2 probes, both launched in 1977, are the first man-made objects to enter interstellar space within the recent decade. Even though the Voyagers are delivering data from outside the heliosphere, they can only report on circumstances in their immediate vicinity. Scientists have learned to map the heliopause's broad outlines by monitoring emissions from energetic neutral atoms, ENAs, which are created by interactions between the solar and interstellar winds, but much of this transitional area remains a mystery. For more amazing content, be sure to subscribe and turn on post notifications. In 2012, Voyager 1 passed through the heliopause at a distance of 121.6 AU from the Sun, and in 2018, Voyager 2 accomplished the same. Zernstein and his co-workers discovered that throughout this period, the heliopause surface moved by tens of astronomical units. For example, the heliopause expanded for years after Voyager 1 passed through it, making it appear as though the probe was following it. However, the boundary never again caught up to the probe. Voyager the 2nd of May have surfed the growing heliopause for several years before crossing into interstellar space. Based on current understanding, Voyager 2 remained in the heliopause as late as the middle of 2016, inferring that Voyager 2 was barely within the heliopause in mid-2016, and that the heliopause must have been extending outward for some time before the spacecraft ultimately passed it in late 2018. The experts at NASA are still scratching their heads over the nature of this mysterious power. Watch the next video to learn the true nature of this unknown power.